Hello, in this video we're going to be talking about transforming quadratic functions so that you can move a parabola around and not have the vertex at 0, 0 all of the time and not have the parabola opening up all of the time. So our essential question is going to be, how do the constants a, h, and k affect the graph of a quadratic function g of x equals a, parentheses x minus h all squared, plus k? Okay, the parent function of the quadratic family is f of x equals x squared. And just to recall, when you have f of x equals x squared and you graph that on a coordinate plane, an xy axis, you get a parabola where the vertex right here is at the origin. That's the point 0, 0. So again, we're going to be moving the parabola using a, h, and k. Okay, so let's go over some things that you should have learned previously when you were experimenting with parabolas in Desmos. We have our core concept here of horizontal translations. Horizontal goes like the horizon does, so it's left and right. Okay, you're going to move your parabola horizontally by either adding or subtracting inside of the parentheses along with the x. Okay, notice here, if h is less than 0, you're going to move it to the left. Now, when they say h is less than 0, that's a negative number. X minus a negative number, x minus a negative number turns into x plus a number. So when you add right here, that's going to move it to the left. Okay, when you subtract inside the parentheses, that's going to move it to the right. Okay, so inside the parentheses is actually backwards of what you think it might be. Vertical translations is when you move your parabola up and down. Okay, and that actually makes perfect sense of what you think it should be, right? When you add a number, it moves up. When you subtract a number, it moves down. We can reflect our function over the x-axis. And the way that we do that is we put a negative in front of our function. So the a value is actually going to be a negative value, and that will flip our parabola over the x-axis. Okay, and then last but not least, we might stretch or shrink our parabola vertically, and we do that by multiplying by a number a that is either greater than 1, and that will stretch it taller, right? It looks like it gets skinnier, but really we're stretching it taller. Or a number that is less than 1 but more than 0, so like 0.5 or 0.2, right? And that's going to flatten our parabola flatter. Okay, so let's put those to work. Here we have 6 different functions, and we're going to analyze the change in each function so that we can match these graphs down here at the bottom with the correct function. Okay, so this first one right here, I have a negative symbol in the front, so that means I'm looking for a parabola that opens down. That might be that one, or that one. And then minus 2, I recall from the previous slide that minus moves the graph to the right. I don't have anything moving the graph up or down. This one has been moved left and down, so it's not that. This has been moved left and up, not that. This is my last remaining function. So again, the negative in front means the parabola opens down. The minus 2 inside means it has been moved to the right. Here I have no negative symbol in front, so it's a parabola that opens up. Here are my 3 parabolas that open up. Minus 2 inside the parentheses means it has been moved to the right. So this function has been moved to the right. This function has been moved to the right. This function has been moved to the right. Plus 2 means the function has been moved up. This function has been moved down. It's not that one. This function has been moved up. This function has not been moved up or down. My next one, I have a negative in the front. So again, my parabola opens down. So that leaves me with this choice or this choice. Plus 2 on the inside means that it moves to the left. Both of these move to the left. Minus 2 on the outside means that it moves down. Only this function has been moved down. This next one, we have a 0.5 on the outside. That's a positive number, and since it's less than 1, it means that my parabola has been flattened. Okay? Now, it's a little hard, but I can tell between this parabola and this parabola that one of them has been flattened. Okay? But let's keep looking at the rest of the function. Minus 2 means that the function has been moved to the right. They have both been moved to the right when I look at the vertex. Minus 2 on the outside means that it has also been moved down. This one has been moved down, the vertex right here, the bottom of the parabola. And this one, the parabola also looks wider, which is another way of thinking it looks flatter than this other function. All right, and now we're down to 2. We have this next function. 2 multiplied in front stretches the parabola taller, and then minus 2 on the inside with x moves the parabola to the right. This has been moved to the right, and it's skinnier than the other parabolas, which means it has been stretched taller. And then let's just check this last one to make sure. Negative in front, yes, it opens down. Plus 2, it needs to be moved left 2, that's good. Plus 2 on the outside means it needs to move up 2, and that's good. Okay, well done, guys. And next, we have this one. We need to know how to write transformations of quadratic functions. Okay, when you have f of x equals a times the quantity x minus h squared plus k, this is known as vertex form because the h and the k tell you exactly where the vertex is going to be located. Okay, your h tells you that the vertex has been moved left or right. That's your x value of your vertex. Your k tells you that the vertex has been moved up or down. That's the y value of your vertex. Okay, the a indicates whether there's a reflection going on, and it also indicates whether there's a vertical stretch or shrink. So let's look at this problem right here. Let the graph of G be a vertical stretch by a factor of 2, so that's your a value. Let me just write that down. That's going to be an a value. And a reflection in the x-axis, so that means that we have a negative 2 as the a value. Followed by a translation of 3 units down, right? So 3 units down means that after the parentheses, I am subtracting 3. It doesn't tell me if it's been moved left or right, which means it hasn't been, right? We want to write a rule for G and identify the vertex. So here we have our solution. Identify how the transformation has affected the constants in vertex form. So we have our reflection in the x-axis and vertical stretch by 2. Both of those mean that a is negative 2. A translation 3 units down means that k is negative 3. So when we replace negative 2 for the a, 0 for the h because we have not moved it right or left, and negative 3 for the k, we simplify this. X minus 0 just stays x. Keep the squared, negative 2x squared, and then minus 3 at the end. Okay, I know that because the vertex has not been moved left or right, the x value of the vertex is 0. And because the vertex has been moved down 3 units, the y value of the vertex is negative 3. So if I were to sketch that, we would have our vertex at 0, negative 1, 2, 3, and we would open our parabola down from that point. Okay, thank you for watching.